so we are still in 5.1, and I'm going to look at a few applications. Let's choose if you'd like to choose yourself. We only looked at, actually, we only looked at two examples, I think. Let's do some more with both substitution and elimination, and then a word problem. Okay, so let's look at 38. Let me ask you whether I'm skewed or I'm focused here. Can you see? If you have any questions, stop me anytime. So 38 on page 555. 4x minus 2y equals 2, and 2x minus y equals 1. This is a typical situation in which I would definitely use elimination, but you can use substitution. As long as one of these coefficients is 1 or negative 1, you can think of substitution anytime. If this coefficient were 7, for example, or any other number but 1, I would have never thought of substitution or applying substitution here. So since I would like to eliminate either x or y, it doesn't matter. If you want to eliminate x, we should multiply the second equation, both sides of course, by negative 2. So when we use elimination, keep the equations together. So I have 4x minus 2y equals 2. And when I multiply the second equation by negative 2, I get negative 4x plus 2y equals negative 2. And when I add, I get 0 equals 0. So you can say, well, I didn't get a solution, but I got a true statement. So the question is, which of those three situations we are encountered here? We just encountered. Is it one with a unique solution? No, because I didn't get x and y. Is it the other one in which the system has no solutions? No, because I got a true statement. So it must be this one, in which both lines are identical, and there are infinitely many solutions. The system is consistent. So not this and not this. Consistent system. And the equations are dependent. Dependent equations. Okay, so let's look at another situation. What about 32 on the same page? In 32, we have 6x plus 2y equals 7. Stop me if you have questions, please. And y equals 2 minus 3x. This is already set up for substitution. You'll see the second equation is already solved for y. So all I have to do is replace in here y by 2 minus 3x, because that's what y equals to. So we have 6x plus 2, and in parentheses, 2 minus 3x equals 7. We will distribute 2 times 2 and 2 times negative 3x. Now we notice that these two go away, and I'm telling you that 4 is the same with 7. What would you say? I hope I never say that to you, because you should say you lost your mind. Exactly. Exactly. So from the three options, again, this is the first one, here is the second one, and here is the third. Obviously it's not this. Obviously it's not this. This one has one solution, this one has infinitely many solutions. It must be this. Lines must have the same slope. Parallel lines, no solutions. Exactly. Very good. Let's look at 26. 26 is kind of one of the most difficult ones, if you'd like. Here's why. You'll see in a moment. No, actually it's not 26. It's 28. Sorry. So 28. Here's why. 2x plus 3y equals negative 16. And 5x minus 10y equals 30. Obviously, I would not even think of substitution here, and you may ask why. It's because if I substitute for x, I will move 3y, but then I will divide by 2, and I'll have a fraction to plug in here. So I don't want to complicate things. I want to simplify things. So no, substitution would not be a choice here, our choice here. But then elimination will. But the thing is that regardless of what we decide to eliminate, we will have to multiply both equations by a number. A different number, of course. So if we decide to eliminate x, then the least multiple here is 10. So I need to multiply this by 5 and this by 2. One of them has to be negative so that they cancel out. So that's why I'm saying this is maybe the most difficult one, in which I have to multiply both equations by a number in order to accomplish eliminating one of the variables. So if I want to eliminate x, I will multiply this, let's say, by 5 and this by negative 2. So keep them together, keep the equations together when you use elimination. So 10x plus 15y equals negative 80. And we multiply by negative 2, negative 10x plus 20y equals negative 60. And I accomplished what I wanted. I wanted to eliminate x. Now I perform the operations I see, and this is 35y, and this is negative 140. And I know that 35 times 2 is 70, and there is, when I divide, it's going to be negative 4, right? Y equals negative 4. Is this enough? No. Because I only determined y. So I need to determine x as well. So how do I determine x? I go back anywhere. It doesn't matter where. Let's say I go back to the first equation where I write 2x. Plus, well, 3 times negative 4 will be negative 12 equals negative 16. I will add 12 to both sides, and I will get x equals negative 2. So my claim is this. But who cares? You should say, show me. And I will go back to the original problem and plug it in. What will I plug in? I will plug in negative 2 for x and negative 4 for y. So negative 2, negative 4, negative 2, negative 4. Negative 4 minus 12 is negative 16. Yes, it is. Negative 10, but plus 40. Negative 10 plus 40 is indeed 30. Yes. So I will say absolutely yes. I checked. Any questions? Any questions? Okay, so let's look at a word problem this time. Problem 80 on page 559. And I need to be ready with more paper here. Okay, A new restaurant is to contain 2 seat tables and 4 seat tables. So I'm going to say type X and type Y. 2 seat, 4 seat tables. Okay. Fire codes limit the restaurant's maximum occupancy to 55 customers. Total or max 50, was it 55 or 56? 56, yes. 56 customers. That's the maximum. If the owners have hired enough servers to handle 17 tables of customers, how many of each kind of tables should they purchase? Max, 17 tables. Let's read the problem one more time. So they say that a new restaurant is to contain 2 seat tables and 4 seat tables. The fire codes limit the restaurant's maximum occupancy to 56, total maximum, 56 customers. And they have a maximum of 17 tables. So we're asked to find how many of each kind of table should they purchase. First of all, we have to establish how many variables we have in the problem. How many unknowns? What are we looking for? And how many are they? And the answer is 2 variables. X is the number of tables that have 2 seats, and Y is the number of tables that have 4 seats. Therefore, we have to come up with 2 equations, a system of 2 equations. Can anyone give us any of the 2 equations that we have to write? Any of the 2? Well, we know that the total number of tables is 17, and we can't exceed that. And we also know that we have a total number of 56 customers. So 2 customers per X means a total of 2X. 4 customers for each Y, it means 4Y. Now you have 2 ways actually. You have the possibility of applying substitution or elimination. You can substitute solving the first equation for X or for Y in the second equation, or you notice that you can divide this by 2 and simply multiply the first one by -1 and get negative x negative y equals negative 17, and x plus 2y equals 28, y equals 11. So they have 11 tables that hold 4 customers, and because the total number of tables is 17, obviously x must be 6. So I claim 6, 11 is the solution. But again, I have to show you why, which means I have to go back to the original problem and replace 6 and 11, 6 and 11, and make sure that both work. 6 plus 11, 17, yes. 12 plus 44, 56 indeed. So now I'll say it's a yes. That is the correct solution. 6 tables with 2 seats and 11 with 4 seats. Any questions? We want to work on another problem. We want to continue. Any preference?
Can we do one more word problem?
Yes, very good. So let's look for another. I'm looking looking on same page, 559. Let's look at 82. I think I'm on 4. Yes, I'm on 4. So 82 on page 559. When an airplane flies with the wind, so here is the speed of the airplane and this is the wind. So when it flies with the wind, it travels 800 miles in 4 hours. Okay, now against the wind, it takes 5 hours to cover the same distance. So this is scenario number 1, and here's scenario number 2. Let's say here is the airplane, and here's the wind. It covers the same distance of 800, but this time it takes 4 hours. With the wind, it takes 5 hours, of course. Yeah. So with the wind, it takes 4 hours, and against the wind, 5 hours to cover the same distance. Find the plane's rate in still air and the rate of the wind. So obviously, when the airplane gets help from the wind, the actual speed of the airplane is not just what the airplane can do, but also it's increased by the speed of the wind. Imagine you are riding your bike and there is a tailwind, a backwind. You're riding faster, even if you can't ride faster on your own. So you're getting an added speed. The same thing here. So sometimes, depending on the western winds, from let's say from Baltimore to Alaska, it may take 10 hours. I'm just making up stuff because of the headwind. But when you come back the same distance, it may take only 6 hours because of the wind. Okay? So when we travel with the wind, our actual speed is increased by the speed of the wind. When the wind is a force against us, then the airplane's speed is reduced by the wind of the speed of the wind. I'm going to have to give it some names. I'm going to say this is X and this is Y, and this is X and this is Y. Now we have to remember that we are talking here about uniform motion. Uniform motion relationship is distance equals rate times time. Distance, rate, time. So obviously we have two variables, X and Y, in both scenarios. So we have to create two equations, a system of two equations, one coming from the first scenario and the other one coming from the second scenario. And of course we are using distance equals rate times time. So can anyone give us an equation for the first scenario? The distance is 800. The rate has to be the combined rate by increasing this rate with the wind rate or speed. And the time is given to us as 4 hours. Can anyone come up with a second equation?
800 equals X plus Y.
Careful.
Multiplied by 5.
Careful.
Oh, subtract.
X minus Y multiplied by 5. Agreed?
Yes.
Because the speed will be reduced by this. Now we have, all of a sudden, we have a force against us, which means that this speed will reduce our speed by whatever that is. Good. Of course, I'm going to divide both sides here by 4, eliminate that, divide both sides by 5. So the new equation becomes x plus y equals 800 over 4, which is 200. And then x minus y equals 800 over 5, which is 160. And now this is already set up the way I wanted it to be set up. X plus x is 2x. 200 plus 160 is 360. Therefore, the speed of the airplane must be 180. Of course, miles per hour. And this is not enough because I have to determine the speed of the wind, but that's not a problem. If this is 180, how much is y? Their sum is 200, and I determine one of them, which is 180. What should the other one be?
20.
20 miles per hour. So I claim 180, comma 20. And again, you can say, who cares? Show me. And that's what I need to do anyway. So I'll put 180 and 20 and see what happens. 200 times 4 is 800? Yes, it is. 180 minus 20, 160 times 5 is 800? Yes, it is. So I will say definitely yes. I checked. Any questions?